Okay, let's no. Why is it it never optimize video with AI? Alright, so let's see. My if my stream is good. Let's see on YT. Looks okay. Let's see on the TikTok. Okay, so mukhang okay rin naman dito. Ah, shoot. Oh no, feedback na naman. Okay, where did I put that? Saan na ba tayo? So, oh no. I think I need to send the pages na ano. Wala akong ChatGPT dito sa isang iPhone ko. Oh no. Need to take a picture. Medyo mahaba pala to. Shoot. Bagay, meron tayo hanggang 10:30. Need to kasya ba? I think kasya. So, lagyan na natin lahat. architecture significant. Many architects believe that if architecture decisions involves any specific technology, then it's not an architecture decision, but rather a technical decision. This is not always true. If an architect makes a decision to use a particular technology because it directly supports an architecture characteristic such as performance or scalability, then it's an architecture decision. Michael Nygaard, Nygaard, a well-known software architect and author of Release It Pragmatic Bookshelf, address the problem of what decision an architect should be responsible for, and hence what is an architecture decision, by coining the term architecturally significant. According to Michael, architecturally significant decisions are those decisions that affect the structure, non-functional characteristics, dependencies, interfaces, and construction techniques. The structure refers to decisions that impact the pattern or styles of architecture being used. An example of this is the decision to share data between a set of microservices. This decision impacts the bounded context of the microservice, and as such affects the structure of the application. Non-functional characteristics are the architecture characteristics that are important for the application or system being developed or maintained. If a choice of technology impacts performance, and performance is an important aspect of the application, then it becomes an architecture decision. Okay, depends. Question natin, baka dito na yung post. Ayan, nakita na. Ayan, tapos sagutin na natin yung mga questions. Dependencies refer to coupling points between components and or services within the system, which in turn impact overall scalability, modularity, agility, testability, reliability, and so on. Interfaces refer to how services and components are accessed and orchestrated, usually through a gateway, integration hub, service bus, or API proxy. Interfaces usually involve defining contracts, including the versioning and deprecation strategy of those contracts. Interfaces impacts other using the system and hence are architecturally significant. Finally, construction techniques refer to decisions about platforms, frameworks, tools, and even processes that, although technical in nature, might impact some aspect of the architecture. Finally, construction techniques refer to decisions about platforms, frameworks, tools, and even processes, all through the technical in nature might impact some aspect of the architecture. Architecture decisions ADR. Architecture decisions records. One of the most effective ways of documenting architecture is through architecture decisions records. Paano kaya ito? How this one works? ADRs were first evangelized by Michael N. in a blog post and later remarked as an adapt in the ThoughtWorks Technology Radar. An ADR consists of short text file, usually 1 to 2 pages, describing specific architecture decisions. While ADRs can be written using plain text, they are usually written in some sort of text document formats like ASCII doc or Markdown. Okay. Alternatively, an ADR can also be written using a wiki page template. Kailangan ko na mag-start mag-document. I need to start documenting the architectures before it's habang nag-start pa lang kami. Tooling is also available for managing ADRs, not price, co-author of Growing Object-Oriented Software Designed by Test, Addison Wesley, as written an open source tool called ADR Tools. Let's see. ADR Tools. Okay. Dito. What the hell is that? Paano to? How this one works? Yeah, I'm going to search in YouTube on how this one works. Ito, architecture decision records. Architecture decision records.
Would you like to learn about architectural decision records? If so, this video is for you. In this video, we will cover what are architectural decision records. I'll give you some best practices on maintaining and creating architectural decision records, and I'll talk about why we create architectural decision records as cloud architects, enterprise architects, or any architect for that matter. So to begin with, what is an architectural decision record? Well, it's a very simple, usually one-page document that explains architecturally significant choices. So what is the context around the architecture that we did? What were the options we considered? And what did we ultimately decide? With the explanation of the rationales and also looking at what actually happened after we actually created this architecture. So it gives us something to very quickly look at and say, here's what we were trying to do. Here's where all the things we considered, and here's what happened. Now, as a general rule, we're only going to write these ADRs or these architectural decision records for things that actually move an outcome or a non-functional requirement. So they affected the business somehow in a positive way. Now, we may create them for security. We may create them for resilience. It could be things like compliance or data boundaries or even the vendor platforms we chose and why. But we're creating them for things that are architecturally significant. Now, every architectural decision record, typically speaking, will have an owner and a life cycle. Which means even if we create an architectural decision record, when we change directions or go in another way, we don't throw out that architectural decision record. We supersede the old record with a new one, but we're never deleting the history. So we constantly want to know what we did, why we did it, and what were the ultimate outcomes of why we did it. So if it didn't work, we don't want to use it again, or if one of those decisions didn't work, so we never want to go back and erase history. And the key is we're putting evidence in these architectural decision makers. So we're going to link benchmarks, experiments, any risk analysis we did, any trade-off analysis and tables we may have created or diagrams. So someone looking at it can really say, okay, in less than a minute or so, I understand what happened. And that's the point. We're trying to create a single source of truth for the why. And by doing so, it'll give you a significant benefits later, like accelerated onboarding and a few things, which we'll talk about. So the key here is to remember that every ADR or architectural decision mapping is going to map to a capability, a standard, and some form of objective and key result. So we have a clear context of the architectural choices and the business's intent. So I can give you some best practices on creating and maintaining architectural decision records. The first thing is don't create an architectural decision record for everything. Create it for something that's architecturally significant. So if it moves an unfunctional requirement in a good way, create something to that point. So keep everything else in ordinary design documents. Now, to not make these burdensome, try to create a lightweight template and keep using that template.
Na-restrict pa nga ni TikTok
Almost
kamote.
like the title of it, the status of what happened, the context of what was going on.
Mag-aaral lang eh.
Something fairly quick like that. Don't erase history, because otherwise it'll repeat itself. Now, typically speaking, with these ADRs or architectural decision records, you want to distribute ownership. So anyone on the
Na-restrict
team
pa
is
nga.
but the owner will shepherd their thing through to acceptance. But the point is, you can't put all this burden on a single person. And we want to make sure that these architectural decision records are findable. And somehow we have to catalog them or tag them by domain or product or subsystem or non-functional requirement. We need to be able to find them quickly. And we typically want to attach proof and benchmarks or whatever we have after the fact. Now, why are we creating these architectural decision records? Well, it does a few things. It facilitates much faster decisions. And that way we're not debating the same common things on and on again, because we've already got something, we've looked at it, we've standardized it. It typically helps a lot when we want to onboard new architects or onboard new executives when there's an actual
Medyo gets
architectural
ko na siya.
repository and there's
So
a
that's
history.
really a parang formal document. So mga notes lang din siya pero yun yung but all are related to architecture decisions like yung mga trade-offs. And then ano yung mga parang diagrams na ginamit and the reason why it's this architecture was being chose to anyways, naban pa ako ni TikTok. So bahala na. Title, status, context, sections, and consequences. We usually add 2 sections. Na ito. So idea format. Ano to? Interesting.
Hey everybody, it's Derek Martin from CodeOpinion.com. Have you ever been in a code base and wondered why something is the way it is? Maybe you're looking at the code and see that there's a framework or library or pattern being applied and you do not understand why. So you go ask a teammate if they understand why, and they have no clue either. Here's a way how you can create a log that defines all the significant architectural decisions that were made and the context around them. Your future self will thank you. So there's generally 2 phases that I personally go through when looking at a code base where I'm curious if I see something. Like I said, maybe it could be a library, a framework, a pattern. How to want to ask, decide now text around when a decision, a context, what the decision is, and specifically about the decision.
This document's named by the short noun name. For example, ADR. On deployment on Ruby on Rails or ADR LDAP for multi-tenant integration. Context. This section describes the force at play, including technical. This section to describe our response to these forces stated in sequence. Addition may be proposed if the project stakeholders haven't agreed yet. Accepted if we agreed. If later either changes to or reverse a decision, it may be marked as deprecated or superseded with a reference to its replacement. Consequences. This section describes the resulting context after applying decisions. All consequences should be listed, not just the positive ones. A particular decision may have positive and negative and okay. Cognitech. naman TikTok. Ang ina mo. Fuck you, TikTok. Fuck you. Tindi. Anyways, let's go back. Okay. Interesting tong ADRs na 'to. Parang maganda siya i-follow. The context section of an ADR specifies the process at play. In other words, what situation is forcing me to make this decision. This section of the ADR allows the architect to describe the specific situation or issue. Wait, nasaan na ba ako? The possibility was alternatives when architect requires to document the analysis of each alternative in detail, then an additional alternative section can be added to the ADR rather than adding the analysis to the context section. The context section also provides a way to document the architecture by describing the context. The architect is also describing the architecture. This is an effective way of documenting a specific area of the architecture in a clear and concise manner. Continuing with the example from the prior section, the context might read as follows. The order service must pass information to the payment service to pay for the order currently being replaced. This could be done using REST or asynchronous messaging. Notice this concise statement not only specified the scenario but also the alternatives. The decision section of the ADR contains the architecture decision along with a full justification for the decision. Michael N. introduced a gateway of stating an architecture decision by using a very affirmative commanding voice rather than a passive one. For example, the decision to use asynchronous messaging between services would read, "We will use asynchronous messaging between services." This is a much better way of stating decision as opposed to, I think, asynchronous messaging. Ganito lagi ako eh. I think. I always start with I think. Yeah. Mukhang kailangan ko yung mas commanding. Only the opinion of the architect is stated. Perhaps one of the most powerful aspects of the decision sections of ADR is that it allows an architect to place more emphasis on why rather than the how. Understanding why a decision was made is far more important than understanding how something works. Most architects and developers can identify how things work by looking at the context diagram, but not why a decision was made. Knowing why a decision was made and the corresponding decisions for decisions helps people better understand the context of the problem and avoids possible mistakes through refactoring to another solution that might produce issues. To illustrate this point, consider an original architecture decision several years ago to use Google's Remote Procedure or gRPC as means to communicate between services. Without understanding why the decision was made, another architect several years later makes the choice to override the decision and use messaging instead to better decouple the service. However, implementing this refactoring suddenly causes a significant increase in latency, which turns into ultimate causes timeouts occur in upstream systems. Understanding that the original use of gRPC was to significantly reduce latency at the cost of tightly coupled services would have prevented the refactoring from happening in the first place. Okay. Consequences. Consequences section of an ADR is another very powerful section. This section documents the overall impact of an architecture decision. Every architecture decision, an architect makes some sort of impact, both good and bad. Having to specify the impact of an architecture decision forces the architect to think about whether those impacts outweigh the benefits of the decision. Another good use of this section is to document the trade-off analysis section with the architecture decision that these trade-offs could be cost-based or trade-offs against other architecture characteristics. For example, the decision to use asynchronous fire and forget messaging to post a review on a website. The justification for this is to significantly increase the responsiveness of the post review request from 3100 millisecond 3.1 ms to 3.1 3.1 seconds to 25 ms because users would not need to wait for the actual review to be posted, only the message to be sent to a queue. Well, this is a good justification. Someone else might argue that this is a bad idea due to the complexity of the error handling associated with an asynchronous request. What happens if someone posts a review with some bad words unknown to the person challenging this decision? That issue was already discussed with the business stakeholders and other architects. It was decided from a trade-off of perspective that it was more important to have the increase in responsiveness and deal with the complex error handling rather than have to wait to asynchronous provide feedback. Oh, okay. Which of the context trade-offs architecture decision thus avoiding? So, meron tayong context. So, meaning, ano yun, is parang details about that architecture decision. Bakit parang justification of why it was accepted, ganun. Or why this was rejected, superseded, something like that. Consequences is more on the trade-off, no? Okay. Compliance section of ADR is not one of the standard sections in ADR, but it's one we highly recommend adding. The compliance section forces the architect to think about how the architecture decision will be measured and governed from compliance perspective. The architect must decide whether the compliance check for this decision must be manual or if it can be automated using fitness function. Nakalimutan ko na yung fitness function. If it can be automated using fitness function, the architect can specify in this section how the fitness function would be written and whether there are other changes to the code base are needed to measure these architectural decisions.
everyone. Happy New Year and welcome to Software Architecture Monday. My name is Mark Richards, and in this lesson number 215, I'm going to talk to you about what's called fitness function driven architecture, show you what it is and how to apply it. I talked about fitness functions back in lesson 73 a long time ago and kind of introduced the concept of a fitness function. Then in lesson 139, I talked about aspects of fitness functions, kind of when to run those. Well, today I want to talk about a concept called fitness function driven architecture. Just to review, an architectural fitness function, which by the way was first identified or defined in Neil Ford's book Building Evolutionary Architecture,
Okay ta.
along with
Kano yan? Building Evolutionary Architecture. Amazon. Nangokolekta ng libro. Oh my God, 3K. Teka, ano yung... Oh, mukhang interesting to ah. Okay, ChatGPT. Meron ba akong parang book reading? Sa Gemini. Baka sa Gemini ko ginawa yung plan ko na yan. Yeah, I think I put that in Gemini. Workflow engine. Yeah, I see it seems like that I put it in Gemini. Ah, yeah, it's in Gemini. Yun ito, Neil Ford na naman. Ay, parang interesting box, no? It's a specialization book. Okay, so I'll keep it in my wish list. Probably next year, I'll buy this. Okay, let's go back. Saan na ba yan?
Rebecca Parsons and Patrick Quah is basically some
I'll just abuse
objective
TikTok na lang.
integrity assessment
It's total,
of
I'm
some
already
sort
blocked.
of architectural characteristic. Effectively, it's a way of being able to test and validate your architecture. Now, there's a lot of tools that we use in our infrastructures and that basically are, in fact, fitness functions. Anything that gathers, analyzes, and reports on metrics is effectively a fitness function. However, many times we have to actually build these ourselves. I call these custom fitness functions. Those kind of metrics and analysis we're trying to gather and observe that goes beyond what the tools can provide us. Now, fitness function driven architecture effectively are fitness functions that describe an architectural goal that teams strive to eventually achieve. Very similar to what we do in TDD, test driven development. So we start with a test, a fitness function that measures some sort of either structural, process, or even operational kind of metrics. And then we start to work on our architecture. And of course, the test fails. We haven't achieved our goals. We continue to work on the architecture, still having that test fail, until finally we do enough architectural changes to where that test passes. And this is the idea of fitness function driven architecture. Again, kind of the same concept as TDD, except for architecture. So let me show you an example of fitness function driven architecture in action. And what I'm going to use to show you some examples of how you can use this is our SysOps squad architectural kata that we kind of introduced and outlined in our book, Software Architecture, The Hard Parts. Now, the SysOps squad, briefly, is a trouble ticket system where customers, when they buy electronic devices, can also choose to purchase a support plan. And if they have issues, they can enter a trouble ticket
so it gets
and
gonna.
our customer facing.
Alright. Let's proceed na. Launch. I recommend is adding note section. This section includes various metadata, the ATRs such as following: original author, approved date, approved by, superseded date, as modified, date modified. Even when storing ADRs in a version control system such as Git, additional meta information is useful beyond what the repository can support. So we recommend adding this section regardless of how our ADRs are stored. Storing ADRs. Once an architect creates an ADR, it must be stored somewhere, regardless of where ADRs are stored. Each architecture decision should have its own file or wiki page. Some architects like to keep ADRs in Git repository with the source code. Keeping ADRs in a Git repository allowing to be version and track as well. However, for large organization, we caution against this practice for several reasons. First, everyone who needs to see the architecture may not have access to the Git repo. Second is this is not good place to store ADRs that have a context out this outside of the application Git repository, such as integration architecture, enterprise architecture decision, or those decisions common to every application. For this, I recommend storing ADRs either in a wiki or a wiki template or in a shared directory on a shared file server that can be accessed easily by wiki or other documents rendering software. Shows an example of this directory wiki page navigation. The application directory contains those architecture decisions that are specific to some sort of application context. This directory is subdivided into further directories. Common directory is for architecture decisions apply all applications, such as all framework-related classes with container. Kailangan kong gumawa nito. Kailangan kong gumawa ng ganitong ADR. Hirap pala maging software architect. Parang gusto ko lang mag-developer na lang ako ah. ADR's documentation. Documenting software architecture has always been a difficult topic while standards are emerging for the models such as Software Architect Simons from C4 model or the open group Archimate. C4 model. Ba't libro? Wala siya? Oo, mukhang medyo mukhang medyo madami to. Interface, no? Shish. Kailan kaya ako makakapagawa ng ganitong very detailed? I see. Ito gumagawa na ako nito. Pero yung ganito medyo kakaiba to. Alright, so tooling. Anyways, I'll try this. C4 model. Archimate naman tayo. Archimate. Let's see. Archimate. Interesting. Kasi parang luma na niya, no? Parang maganda pa sa draw.io. I think draw.io na lang ako pag ganito. Kaya ng draw.io to. What is TriGT? Sorry, I'm not sure if, what is that? Standards. Yeah, actually standards is the one of those things na medyo ano siya, mahirap i-implement. Architecture decision exists within architecture in case study going gun. The use of event-driven architecture splitting up TP during Oceaner. The use of real-time transport protocol RTP for video capture. The use of single API layer and the use of publish subscribe message are just a few of the dozens architectures that are made for this ocean system. Every architecture decision made in system, no matter how obvious, should be documented and justified. It is one of the architecture decisions within the Going Gun system, which is use of publish subscribe between the bit capture, bit streamer, and bit tracker service. EDR4. Ito may sample pala siya. There's a sample. The bit capture service receiving from online bit from a live bidder. I'll try this kind of documenting. But what is that? I wonder where should I start first. Maybe I should start first in Git. I'm going to use Markdown muna siguro. We will require clustering and high availability. So, commanding nga siya, no? We will require. Compliance. We will use periodic manual code and design reviews to ensure that asynchronous format is being used between the author. Subashi. Okay, may notes siya. Interesting. Oh, tapos na pala. Shit. Chapter 20 na ako tomorrow. Oh my god. So at least makatatlo ko until I think, yeah. So my target is at least chapter 22 at best. But I don't think I will reach chapter 22 because this chapter 20 is quite a lot. Yeah. Almost 16 pages. And mukhang matindi yung mga topics niya. Either baliktad ba or parang nakakrap yung aking. Akala ko nakakrap yung webcam ko. Yeah. Alright, so let's try reading kung ano yung binigay ni TikTok. Ay, ni ChatGPT. This section is where it becomes operational. You now move when the decision may exist, what clarifies as an architecture decision, how to formalize it. But all decisions are architecture decisions. Decision is architecture only if it material affects structure, characteristics, or system behavior. Context structure impacts architecture stellar boundaries. Example, shared TP versus isolated. This is a quantum defining. Non-functional characteristics, performance, scalability. This is your primary driver axis. A technology choice becomes architectural only if it affects characteristics, dependencies, coupling between service components. This is your hidden complexity driver. Interfaces, how services communicate, contracts, versioning, orchestration. This is where most distributed failures originate. Construction techniques, frameworks, tools, processes usually ignored, but it affects architecture behavior. This decision filter you must internalize before making the decision. As this does impact structure. Does this impact structure characteristics dependent? If not, delegate to devs. If yes, idea-worthy decision. ADI turns architecture from implicit non-explicit traceable decisions. Why ADR matters, deep insight. With ADR, execution disappear, email, anti-pattern, reasoning disappearance, Groundhog Day. Audio solve all these three anti-patterns simultaneously. Standard sections, short, precise, removes ambiguity, use async messaging between order and payments. Status, proposed, accepted, superseded. Critical concept superseded. This is not version, it creates a decision lineage. Crap. Naka-excite parang gusto ko tong itry. Insight. You're documenting architecture incrementally by a decision. Async messaging improves responsiveness, increase error handling. If this is not documented, future engineers will correct your design incorrectly. Oo nga, no? It makes sense. So, para alam nila why I was able to come up with the decision. So mas nagwe-weigh in ng improving responsiveness than the increase than the error handling complexity. Manual review, automated, fitness function, this advanced architecture moving. Notes, metadata. I will start doing this. Okay, so my question is, if I'm going to create an EDR, do the EDR needs to be finalized before starting the development? Wala kaya nangyari sa akin to eh. Before, I didn't use NATS or event-driven or event bus. Then, yeah, it's kinda coupled the execution service and the workflow service in a way that workflow service needs to be aware to the API endpoint of the execution service. So after introducing event bus, now execution service does not need to know the workflow service does not need to know execution service. So just need to know the event bus and the contract or the structure that needs to be passed to the event bus. Anyways, hindi ko masasagutin yung mga questions niya. Parang feeling ko kaya ito na isang bultuhan. Itong part rin na to. Parang mas maganda siyang i-take as whole part yung quizzes niya instead of every topic. Nasa rest na ako. Yeah, I will start ATR tomorrow. At least 1 ATR lang siguro or 2 ATRs. Pero kung may ATR ako, Okay, so yung mga involved sa development. Okay, tama to. This is what I'm doing currently. Actually, hindi ko siya nila-document. Kasi via Git lang. Via chat-chat lang. Yeah, I'm going to upgrade my current process. Okay. I guess that's it. So, it was a good reading. Chapter 20 pala to. Chapter 19. CH19. Ay, Cognitech. Let me check pala muna ito. Clojure sila, no? Company siguro to ni Uncle Bob. Kaya nga nito. Cognicast. Okay. Mga podcast ba to? Okay. Ano lang siya? Podcast lang siya. Pero audio. Pero more on closure siya, no? Anyways. I guess that's it. So, laro-laro muna ako. Suko din.